Okay, before we start, I would like to show you three various possibilities in which the question can come. Now, let me start with number one. Number one, this is one of the possibilities. In this question here, you will see that we have what? A 2 ohm resistor connected in series with the battery and this key, and then the jockey is connected to a part of the constituent wire, where the constituent wire has been labeled AB. A at this end and B at the other end. You can see A here, letter A here, and see letter B here. Now, this is how it works. Very simple. Carry the positive side, which is this place. Positive side is this place. Can you see it? Connect it to one side of the resistor. A resistor has neither positive nor negative. Any part you connect to the positive of the cell becomes the positive, while the other one automatically becomes negative. So like in this case, I have connected this, or this part to be connected to the positive part of the cell. The longer terminal is the positive, while the shorter one is the what? Negative. Then if we follow this other direction, the other leg or terminal of the resistor or wire, you can call it, connected to what? The constant wire, one end of constant wire, and what? Of course, the positive or the voltmeter. How do I know? If you trace it this way backwards, we are going back to the what? Positive of the cell. Therefore, this side must be positive of the voltmeter. If you connect negative to positive this way, your voltmeter will deflect towards the left hand side, which will not give you the appropriate reading. Now, the negative side of the voltmeter is connected to what? The jockey, which will be used to drag gently on the what? Constituent wire A, B. It has been labeled, and this is the jockey itself. And the key, the negative terminal of the cell is connected to one side of the key. A key has neither positive nor negative, and the remaining side of the key is connected, of course, to the end of the constituent wire. With this connection, we will be changing the value of what? The length of the constituent wire X. As we are dragging the jockey along the X in this way or the other way, the voltage of the voltmeter will be changing, which is the what? The voltage across the part of the constituent wire that is in connection with the what? Jockey. This is as simple as this. Then the second one could be this. In this second one, you can see what happens here is that your constituent wire and the resistor, don't mind the shading, it's still resistor because the diagram tells you 2 ohm resistor, are connected in parallel, and the voltmeter across the two of them. Of course, you know, when resistors are connected in parallel, it is the same voltage that flows across. Now, how do you connect this thing? Very simple. Number one, 4 things meet here. 4 things. You can see 1, 2, 3, and then 4. Number one, the positive of the cell, you carry it. The positive of the voltmeter, I told you positive must be to positive 2. One side of the constituent wire, one side of the resistor, you tie all the 4 of them together. Come to this end, 4 things again meet here. The negative of the voltmeter, the remaining side of the resistor, the end of the jockey, that is the wire, not the jockey mouth, please. The jockey mouth is this one. And the one side of what? The key, see it here. Tie the 4 of them together. Well, if you have done this thing, you have done the major connection. Then the negative of the what? The cell is connected to one side of the key. Remember, one side had been connected to this place where 4 things meet. Then what you now have left is the what? The pointed mouth of the jockey, which you now use to drag along this constituent wire all the way from here to any of these. Remember, this point is not connected, it's just passing. Okay, so anywhere you draw it and the length in question, the distance from here to here is supposed to be L, then that is the length. And you take what? Voltage reading V. Now, the third one could be this connection. Now, what is the difference here? This connection, this number 3 and this number 1 are similar. The only difference here is that in this case, the voltmeter is connected across the constituent wire, if you can see it now. But in this case, the voltmeter is connected across what? The 2 ohm resistor. But every other connection remains the same. And you can see that the one side of the constant wire is left suspending. Nothing is connected to it. Is that okay? So in other words, that is to say the constant wire and the what? 2 ohm resistor are still connected in what? Series. Don't don't forget that the constant wire start from this place and end here, please. Not from this place. What start from this place to this place is the resistor. Look at it here. The constant wire will start from here and end here. So any side you drag it, you will get the value. So and this is the what cell, and this is the key, and this is the voltmeter. So we are going to pick one, which is this number one, and connect it accordingly. Please follow me. Okay, I've been asked to provide a cell, which is this. You can see it. This is a cell. This terminal is a positive. This side, the flat, the one that bends on the inside is a negative. For someone that will be using 2 volts accumulator, is still okay, or 2-volt battery. Now, I am using key with the key plug. This is it. We insert it. If you are using switch, they are still the same. It's to make and break circuit. Look at the jockey. This is the jockey. This is the point that I will make contact with the constant wire. This other terminal will be connected. I believe you can see it. Now, this is the resistor, 2 ohm resistor. I don't know how to help you, physics teacher and other, especially physics teacher who will be providing this apparatus for the student. In science, we don't just go by the values written on it. You have to test. This guy, 2 ohms might be written on it. Believe you me, it might not be 2 ohm. For instance, the 2 ohm I wrote now is written in sellotape, which means this is not from the manufacturer. Even sometimes, when it is from the manufacturer, you could still have a problem when you're trying to what? Identify it. That is why what you do is to run analysis on the instrument or the apparatus you are providing. You could use Ohm's law to get to know the value of this resistor before you supply it for your children. Okay, now coming down to constant wire, I would have had a lot to say, but I don't want to make the video long. You have to understand constant wire. This is not a constant wire, please. This one you see here is a copper wire. Do you get it? This is a copper wire, so don't use this kind of thing. Very important. Now, this one here is a constant wire. Can you see it? Then this is also another constant wire. It's not the shape of the container. Now, there's another one which is nichrome. Nichrome looks like constant wire. This is still constant wire, please. Please, it looks like this, but it is not. Please, labeling is important. Now, coming down to constant wire, we have various gauge. We have 30 gauge, SWG, that is specific wire gauge. It could be 30, it could be 24, it could be 26. The one required in this NECO experiment is 26 gauge. Don't just send somebody to cut for you. Buy it for yourself and ensure the label is there, because the resistivity of a constant wire varies with different watt gauge, and the cross-sectional area also changes. And these things are going to affect the resistance of the constant wire, which will automatically affect your reading. Now, I want to say something about those who want to manipulate. Don't manipulate, because if you manipulate, there are many things you don't put into consideration while manipulating. Number one, you don't know whether the circuit is going to be connected in series, in parallel. And I have showed you different ways. There are still more ways you can connect this with what you've been asked to provide for your children. The most important thing is not that manipulation, but rather how to connect, like I've shown you. It's as simple as that, which I'm going to demonstrate shortly. Number two, when you manipulate, you don't take the internal resistance of the cell into consideration, because The cell is not an ideal voltage supply that has internal resistance 0, which is small letter r. You know, current is E all over R plus small r, where E is the EMF of the cell, like 3 volts, as we've been told to supply, or 2 volts if you are using 2 volts in your school. Then resistance, which is standard resistor R, big R, which is 2. What about the small r, which is the internal resistance of the voltage source or the battery itself? Have you taken it into consideration? Teachers don't do that. They just go ahead and manipulate. And you're manipulating with only a diagram. What if you taught your children how to manipulate with this, and it comes this way or it comes this way? All the values of the voltages in these three different connections will not be the same with the same value of length, because there is analysis you need to run. So do you expect the child to get there and expect the child to use the same manipulation for different connections? It is going to be catastrophic. It's going to be a colossal loss. It's going to be demoralizing, and it is wickedness. So what we do is to teach children how to do it, and once they can do it, then they are set to go. Then another thing, I watched a video where somebody spent 30 minutes to teach how to manipulate. Meanwhile, my children are spending just 15 minutes in all. I mean electricity now. It's as simple as that. I mean, I shock you. Electricity is the simplest of all practical you could ever do. Mechanics can be time wasting. You have to wait if it is simple harmonic motion until you count 20 oscillation and all that. When it comes to heat, there are many factors you cannot handle, because to have a proper lagging system is quite very, very difficult. When it comes to light, light is highly mathematical. If a child does not know how to draw number, how to measure angle this and this, how to project this one such that this one interconnect with this, then take this reading and all that, it is going to be confusing, and children still have problem with tracing light. But with electricity, I tell you, just follow a simple connection. Ensure you as a teacher, you supply the right material. That's why I'm guiding you now on what to do. For this cell, don't use 2, 3 experiment here. Just 2, 1 and 2 is okay. The third one should be replaced. Just like in my own case, in from school, they advise every child comes with their own battery. Some even use Duracell. The essence of using Duracell and not this Tiger cell, they are both Leclerc cell, but that one has a high source of current and stability, but the same voltage. It does not run down quickly. So that is that. Now, ensure your voltmeter is working and is, of course, if you could have a voltmeter that has a higher degree of accuracy than mine is 0.1. If you divide 1 by 10, 1 be the first value over the 10 division, that is 0.1. But I have another one that is 0.06. That is the one I intend to use that day, because the first calibration here is not 1, it's 0.6. When you divide by 10, you will have 0.06. So the higher the degree of accuracy of the voltmeter, the more accurate. But don't forget the range. The range is 0 to 5. So that is what is very, very important. Now, so we are going to go into connection. I've just showed you. Then the essence of the meter you hear is to help me take the reading. That's this. This one is to help me take the reading. And from there, we move over to the constant wire, which I have cut here. You can see the wire here is about 100 cm. Now, I had already shown you the first thing to do. I believe you can see the diagram here. So let me remove it and show you, because it's very, very important now. Okay, sorry, excuse me. Okay, the first thing I'm going to do, like I said before, is to what? Connect this end. And in this end, I told you 4 things meet here. What are the 4 things? The 2 ohm resistor, one side of constant wire, sorry, 3 rather, then the positive terminal of the voltmeter. Why am I saying positive? Because the positive cell comes from here. So I'm going to carry one side of the what? 2 ohm resistor, one end of the constant wire, and the positive, very important, of the voltmeter because of this positive terminal. So let's go. The positive of the what? Voltmeter, I believe you can see it. One end of the constant wire, I believe you can see it. I'm carrying this end, this one, together with this. Then the third one is what? The one side of the 2 ohm resistor. You can see it. I'm using this side. So I'm going to tie the three of them together. Tie them like this. I'm tying them. You just twist them in one direction. That's all. Can you see it? Just twist them in one direction. I've done the connection. The next one I'm going to do now is to carry the other side, this other side of the resistor to the positive terminal of the cell. So look at the other side of the resistor. Look at the positive terminal of the cell. I told you this blue part, or the one that has a protrusion, is the what? Positive terminal. So I'll tighten them together. Twist in one direction and tighten it very well. Tighten it very well, rather, to avoid what? Current what? Fluctuation. It's one of your precautions. So I've done this in, I believe you can see it. I've tightened it, got it. Now the next thing now will be what? The negative part of the cell to one side of the key. Key, it could be any side, it doesn't have to be negative, but negative side of the cell. So this is the negative side of the cell. Can you see it? Now to one side of the key. I had already applied connected sorry, let me. I've already connected wires to make it very, very simple. So you could do that too. Just twist it in one direction. So I've done that. Can you see it? Now the next thing now remaining, I'm done, is what? The remaining what? The remaining side of the key to the end of the concertina wire, the other side. Simple. That's the end of this connection. The remaining side of the key to the end of what? The concertina wire. Just hold on please for me. So to the end of the what? Concertina wire, which I'm doing here. I believe you can see it. So with this now, I am good to go. So I'm good to go. Now, the question says, with the help of the, you are going to close the key. When you close the key, my key plug. When you close the key, look at my key plug here. When you close the key, now you will now use the jockey to tap any measurement of length they ask you along the concertina wire. For instance, we are asked to do, let's say we are starting from 40, 50, 60, 80, 90. So if you are doing 40, you put it here, you measure 40 here, from this place 40. I don't know whether you can see 40. So this 40 here, I'll place it. If I place it, okay, I've not connected my key. I'll place it here, 40. Sorry, I'm not having any. Okay, sorry. Okay, sorry, I've not done one aspect. Please pay up. Yeah, there is something I've not done. Sorry, look at it here. Okay, let me show you. That's why it's very simple. The negative of the what? Voltmeter is supposed to be connected to what? Jockey. I've not connected it. Sorry for that. About that. Look at it. Negative of the voltmeter connected to what? Jockey. So I'm going to do that right away. So the negative of the voltmeter connected to the jockey. Connected to the jockey. So I've done that. Ensure they are not touching each other, right? Okay. And one of the things again, you test on it. Look at it. I did it, was not working. I tested it, and it's now working now. You can see my, let me drop it. You can see it deflecting. Good. So now I'm going to go back and take the measurement, which was what? 40. So 40 cm, 40 cm. So I will use my jockey to touch 40 cm. Then I will not plug my key. I did it this way because there's nobody to help me. And what I have here is what? 0.45. So when L is equal to, right here, When the length is 40 L in centimeter, I'll still show you the diagram, never mind. What I have as my V in voltage, I have what? 40.0. You can use 0.00 in my, I told you in mechanics video. You can use 4.0, 4.00. Then, but for my voltmeter, I'm going to use, this is zero point 0.1 and it's 0.45. 0.45. Look at it here. I have 0.4.40.0, 0.45. Now, I'm going to do for 50. Let me just do it for simplicity sake. 50, 60, 70, 80, 1, 2, 3, 4, 5. That's okay. So I've done for what? For other value. Please, this is not the values I will use. I will decorate the value. Decoration means there will be very straight lines and the points will be in line. Neatness is part of practical. Let's go for 50 centimeter now of what? The length. So to do 50 again, I'll use the essence of the meter rule is just to measure. You could even use, anyway, I would have suggested you use potentiometer, but you are not sure the gauge of the consultant wire on your potentiometer. So don't just go and use potentiometer, please. It's very, very important, except when they say use it. Okay, so 50 cm is here. I'm put my jockey. So when I put my jockey, I'll put this guy. So what I have now is what, 0 0.5. I believe you can see this is 0 0.5. Can you see it here? So I have 0 0.50. This is what 0.50. I believe you saw when I did it, please. There's no manipulation here. It's very, very simple. The next one, I'm going to go for 60 centimeters. 60 centimeters. Ensure the wire is straight. Don't allow it to coil because it might not be the length of 60. This is 60 centimeters now. I'll place my jockey on it. Then I'll put my key here. And what I have is 0 0.6. I believe you can see it. 0 0.6. So there's no marble. 0.60. I'm going to go for 40 cm now. Sorry, 70 cm. 70. The next one is 70 cm. 70 cm. 70 cm. Against, let me put my jockey now. So what do I have? This is 0 0.65. 0 0.65. 0 0.65. 0 0.65. Then I'll do this. This is what I've done so far. Right? I believe you can see it. This is what I've done for. I'm going to go for the last one now. Last one. The last one is going to be 80 cm, 80 cm, 80 cm, 80 cm, 80 cm against what? 80 cm, and what I have here is 0.75. 0. Okay, what I have is 0.8, please. 0.8. Wait, let me do it again to be sure, please. Please, when you are not sure, you do it again. It's very important. Let me do it again. You are not manipulating, but you need to be very sure because of the trend. Maybe my wire wasn't exactly at that point. So it's very important. Let me see what I have. Okay, 0 0.8. Okay, that's correct. 0.80. Now, some people who are teaching manipulation will say is 0.45 now, 0.50 now, is 0.05, add 0.05. Experiment is not like that. Is that okay? But if you watch it, you see the trend. As the length is increasing, the voltage is also increasing. Very simple now, because as you are increasing the resistance, V equal to IR, and it's only the resistance of the constant wire you are taking, sorry, the voltage of the constant wire. As you are increasing the resistance, V equal to IR, the voltage across that particular resistor should also increase. So that's what we have here for now. So We are going to now do our V inverse, L inverse. Then we will now talk about what? Plotting the graph. Follow me and let's go there and plot the graph. Don't remember I told you there are other connections. The one I did is just this one. Please, you could go ahead and teach your children this. It's still the same thing, but the voltage will not be the same. Then you could also teach them this, which I've explained how to connect. Now, if you watch, everything I've spent, both my explanation is 19 minutes. Remember, I'm teaching. If I'm to conduct the experiment, I will not talk to anybody. In the next 5 minutes as a teacher, I'm done. For my children, 10 to 15 minutes, they are done. Now, which one is simpler? Is it to teach children to manipulate something you're not sure, which they might still fail, or to do it the right way and get the right table? This table is okay for me. So we'll go ahead. Thank you. Let's go now and plot the graph.